Hello everybody and very welcome to this video tutorial on the memorandum for MOW 217 class of 2023 practicum 5. My name is Dr. Lucas du Plessis and I'm a senior lecturer in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria. What we'll be discussing is how to get from the information and the step files provided to a detailed mechanical drawing that is shown on the screen at the moment. Okay, so the first thing we do, what I've done in FreeCAD is I've imported the step file of the sub-assembly. And it's important to understand how this lock ring, this outer ring that you see over here, how that fits onto the assembly, because that will enable us to make decisions in terms of tolerances and important features. So what I hope goes without saying is the fact that we want these parts to be concentric relative to each other. In other words, the gear or the pinion gear needs to be concentric relative to the shaft, and then this lock ring needs to be concentric relative to this gear. So with that said, my recommendation would be to make the internal diameter of this lock ring. Okay, in other words, if I can hide a few components here, let's hide the drive shaft, the pinion, the shoulder bolt and the grub screw. So what I would do is I would make this internal diameter one of my datums, definitely, because this surface interfaces with the pinion, as you can see here. Okay, so that needs to be a very concentric, nice finish, tight tolerance diameter. And that will be our primary datum. All right. The second important feature on this part is obviously this hole of the counter bore, where the the hole where the shoulder bolt fits into. Okay, so if I can unhide the shoulder bolt, we know from the information that I provided that this is I think it's an F6 or F8 tolerance. It's a tight tolerance, high precision shoulder. And here you can see, if I highlight that shoulder of the shoulder bolt, it interfaces with this diameter over here. If I can just rotate it, this diameter, that diameter is very important. Okay. Now, having said that, if we orientate this part, if I can just get the right orientation, let's just see. There we go. So if I think it's this one actually, yes. So it goes without saying, and we can measure it, but you can clearly see that that hole is exactly in the middle of these two faces. These faces as such will not be important, as is the case for this outer diameter, but this hole is very important. Its location, its orientation, its round or cylindricity, all those features are very important. All right, so we will then the fact that this hole is symmetric between these two faces it is a logical decision in my mind to make the symmetry plane another datum. Okay, so we will have that surface, that cylindrical surface, as one of the datums, and we will have, in this case, the symmetry plane as another datum. All right, so let's jump right in. So step one, we'll open the manipulator workbench. Okay, we can ignore that warning message. We click on the caliper, we say we want a radius, this radius over here, 9.05 We'll open our spreadsheet. .05 because that's a radius, and this is equals that times 2, so it's 18,1. Okay, so we then go to our tolerance finder spreadsheet, and we can say 18,1, and we want an H7 tolerance for that hole, so it's plus 21, 0. Okay, so if we then go to our drawing, you can clearly see that that is indeed what I've done here. Is I drew in these extension lines. I give it the diameter H7 plus 21 and 0, and in line with the dimension line, I put a leader line for indicating that this is my datum A. And then I also can immediately say this surface needs to be cylindrical to within 30 micron, okay, and we want a nice surface finish of 1,6. Okay, so let's just go back to FreeCAD and let us delete those dimensions and hide this lock ring pinion, and we open the pinion itself. Okay, let's see what is the diameter of this. Let's just see what that diameter is. Okay, so if we click, it's radius 9, so we don't need to even calculate it. It's in other words, 0,19. If we enter 9 here, it's 18, so it's 0,1 millimeter smaller. Okay, so now to understand why I selected to do that, it is because I want a little bit of clearance, a little bit of play in order for all the holes to line up. Okay, and you will see in a minute when we do the measurements. As a matter of fact, I can measure it now. Okay, so if we unhide that rather, and we take a measurement of this diameter, it's diameter 3,05. Okay, so that is again, if we type in 3.05, that's 6,1. And if you remember, the shoulder bolt is 6. So I've got a 0,1 clearance apart from the tolerance. I've got a 0,1 clearance on the nominal sizes between the shoulder bolt and this hole, and then I also have a 0,1 clearance between the lock ring pinion and the pinion itself. Okay, so I've got a little bit of clearance such that this hole that you see now, if I can just orientate it correctly, there we go. So that's better. Okay, so I've got a little bit of clearance and play that will allow me or enable me to insert the shoulder bolt in that hole. Okay, and that's exactly what we want. We can't make it perfect. We can't just go with G7H or H7 G6 tolerances throughout, because then if there's any imperfections, a little bit imperfection, we will not be able to assemble the shoulder bolt, okay, which is obviously something we want to avoid. Okay, so we have our datum A. We've got this cylindricity of 30 micron, because remember now we've got a 0,1 clearance, so between this 18,1 diameter and the diameter 18 of the pinion, 0,1. So if we've got a cylindricity of 30 micron, there shouldn't be a problem with any fitment, and we'll have a little bit of play to insert the shoulder bolt. Okay, so with that done, the next step is then, as I've said, to indicate the symmetry plane as datum B. How do I do that? I've got my extension lines here on this view. Okay, I give it the size, and here you can see the tolerance plus minus comma 2. It's not necessary for a tight tolerance. If I can quickly jump here, there's a lot of play. There's a lot of play here. We can actually measure how much it is. If we select that one, we rotate it a little bit. Select this face. Okay, there's 1 millimeter play clearance there, and the same on this side. There's no need to have a tight tolerance in terms of the 1 millimeter. So there's definitely no need for a tight tolerance in terms of the thickness or the height of this lock ring. So plus minus comma 2, I will definitely not go less than comma 1, and also not much bigger than comma 3. So yeah, I like the comma 2. Okay, so and by this time you already know this very well. The leader line of my datum box is in line with my dimension line. That means my datum B is the symmetry plane. If I can just draw it in here, that's my datum surface, datum B. Okay, now what you will notice is I'm not worried about, let me just undo this quickly. Okay, even though I'm not worried about the size of the height of this lock ring pinion, I am worried about the orientation of these two faces. Okay, so I've specified here a perpendicularity of 25 micron relative to A, and 25 is the threshold between tight tolerances and not so tight tolerances. So 25 is on that threshold, it is a tight tolerance. I did exactly the same on this side. So I want those two faces to be perpendicular to datum A, which is the center axis of the hole. So I want those faces to be perpendicular, because if they are perpendicular, then I've also constrained the flatness of the face to within 25 micron, and hence I've constrained the flatness of my symmetry plane to within 25 micron, give or take. Okay, so that's why I did that. I want a flat surface as datum B. Okay, and then with the fact that it is a tight tolerance, 25 micron, I also ask the manufacturer to take special care of the surface texture of those two faces, 1,6 RA micron. Okay, so with that done, we can now specify our, if I can jump back to FreeCAD, so I've got my datums, and what I can now do is I can now specify the location of this hole that interfaces with the shoulder bolt. Okay, that's a very important surface. All right, how do I do that? Okay, we obviously need to take a measurement, and I actually did already, but let me quickly do that again. Okay, so we want the radius of this surface. It's 3,05. We go to our spreadsheet, it's 6,1. Okay, we already did that earlier. Okay, so it's a diameter 6,1. I extend the dimension lines, and I indicate the diameter 6,1, and it will be an H7 once again. So we can check that H7 tolerance for a 6,1 diameter, and it's plus 15, 0. Right, so if we then go to our drawing, okay, so I show the plus 15, 0. And now I can say I want the position of that hole to be within a 50 micron diameter relative to datum B, which is my symmetry plane, and datum A, which is my center axis. Okay, so once again, the 50 micron is in the ballpark of the 1 clearance that we have. Okay, so I wouldn't go much tighter than 50, maybe 30, but definitely not tighter than that. Okay, and then what I also did was, as for this internal diameter 18,1, I once again specify the cylindricity as 30 micron, and I specify a surface texture of 1,6. Okay, and with that done, this drawing is almost complete. Okay, what is remaining is for us to specify the location of this threaded hole. This is an M5 threaded hole, so let's quickly do that. Okay, so just normal leader lines, I extend them and I say M5 by 0,8. How do I know it's 0,8? The pitch, this is the pitch. Okay, so in the table that's available on ClickUp, the diameters for coarse pitch and fine pitch metric threads, M5 has a 0,8 pitch. Okay, so that's where that comes from. Very easy. Okay, so we can say M5 by 0,8, and then what I've done, once again, constraining the position, and now I can relax even more than the diameter 50. So I've got a diameter 0,1 relative again to datums B and A. Coming to think of that, I think there's actually a better way of doing this. A better way of doing this would be to say, let me just change this to a pen quickly. There's a better way of doing this. So what one could do is say, I don't want blue, I want black. So what one could have done is to say, this is datum C, right? And then instead of this, instead of positioning, we can just say concentric to diameter 0,1 relative to datum C. Okay, that would actually be better. And the reason, I'll explain why in a little bit. Well, next. So when the manufacturer machines this diameter, okay, let me just change back again to let's take green. Okay, so when the manufacturer machines this diameter, it doesn't matter where on the circumference he does that. Okay, he can do it anywhere. But once that hole is machined, this M5 by 0,8 needs to be concentric relative to that hole. And that's why what I've done, what I've shown here, this is actually wrong. I wouldn't do it like this. I would rather do it like that. Okay. So, okay. That's the thread. Let's quickly look at the rest of the features. Okay, so while we're busy here, this is simply a counter bore. This top recess over here is a simple counter bore for the head of the shoulder bolt. So that's easy to dimension on the drawing. All we need to do is we will say the diameter, and we can measure the diameter. Let's quickly do that just for completeness sake. So let me hide the shoulder bolt and click on that. So it's 5,6. So if we go to our spreadsheet, 5,6, it's 11,2. So that corresponds to what I did here. Diameter 11,2 for a counter bore, a plus minus 0,2 tolerance is adequate, perfect. And I put the word counter bore in there. Okay, the depth of the counter bore, we need to measure that quickly. Okay, so we select this icon over here and we click that line, and the depth is 6 millimeters. Okay, so and if we unhide the shoulder bolt again, there you can see we can actually have a relative loose tolerance, but we need to be careful not to make, well, looking at the other end of the shoulder bolt, we can actually relax that tolerance without any fear. Okay, what I did was I specified a plus minus 0,1. I would definitely not go any tighter than that. Plus minus 0,2 would also be okay. That's the depth of the counter bore, and once again I put the word there, counter bore. Okay. Now there are only two features left, and that is to specify the outer diameter. Okay, let me just clean this up a little bit. We can hide the shoulder bolt. Okay, we want the radius. That's 21, so let's put that in our spreadsheet. It's a 42 diameter. The outer diameter of this assembly, of this component, is definitely not important in terms of size. So yeah, I selected a tolerance of plus minus 0,2. Okay, one could actually go even bigger than that. And then I also simply say it needs to be concentric to 0,1 relative to A. You could, for this 0,1, also say 0,2. It's not really that important. Although, yeah, maybe the 0,1 is a good choice here, because obviously the depth of the counter bore is measured relative to this outer surface. So a 0,1 I think is a reasonable tolerance, and the plus minus 0,2 for the size is also reasonable. Alright, then the last feature to dimension is simply this chamfer. Okay, so if we want to do that, yes, we can measure the length even. I think, yeah, let's just see. Now that's not, well, there we go. So by measuring the length, it gives us the X and the Y components of that line, which is 0,6 and 0,6. Okay, so then you already know what the angle is. The angle is 45 millimeters, 45 degrees rather, or 45 degree, and the degrees, and the length is 0,6. Okay, so for that, let's just have a look at the interfacing parts. If we unhide the pinion, yeah, there's nothing even close to that chamfer. Okay, so you could go for that chamfer. I wouldn't go for the tolerance less than 0,1. Okay, and that's exactly what I've done here. I said 0,6 plus minus 0,1 by 45 degrees plus minus 5. Okay. Yeah, you could, for this plus minus 0,1, you could go 0,2 even. Plus minus 0,2 is not a problem. And the plus minus 5 degree is really also not anything tight. Alright. So, yeah, that's the memorandum for the lock ring pinion. And thank you very much for watching.